Hi, good afternoon, ladies and gentlemen. My name is Jeremy Coleman. I'm a regional sales director for Mobileye, and I'm going to talk to you today about what Mobileye are involved in the way of vehicle safety and how we're moving the way towards autonomous driving technology. So first of all, I've got to try and fit in a great deal of information in just a small amount of time. So I'll just want to give a background about who Mobileye are, for those of you who aren't aware of us, the story of what we're involved in, talk about our retrofit ADAS products. There's a case study that I'd like to explain about a project that we're working with in London, in the UK, and then moving forward to how we're moving towards revolutionizing mobility. Some facts and figures. We all know there's a big problem with fatalities and vehicle collisions on the roads today, and I don't need to run through these figures. But what causes these collisions? Over 90% of all collisions are due to what we do ourselves, the human factor. There's many distractions in and around an everyday road vehicle. Whether that's, as it shows on the screen there, the mobile phone, whether it's other in-vehicle technology, whether it's things that are factors that are causing problems outside of the vehicles. It's not possible for our drivers to be aware all of the time of everything what's happening around them. The conclusion. We can retrofit ADAS products or advanced driver assistance system products into any road vehicle now to prevent these collisions. The systems create warnings in time and save lives. So first of all, the story of Mobileye. The company was founded in 1999, and it was developed or born to harness the power of computer vision for automotive safety. If we look across the timeline at the bottom, 2007 we were the first camera radar fusion system into a vehicle using camera vision technology with Volvo. In 2011, we brought the first camera-only forward collision warning alert system to our vehicles. And as you can see, as the timeline moves on across the bottom, we've continuously been the first to bring life-saving technology based on cameras, based on vision technology to vehicles. We're an Intel company, and we joined Intel just over a year ago. And with Intel and BMW, we've announced by the year 2021, we will bring the first fleet of autonomous vehicles to the roads. So after 2 decades, we're the world leader in advanced driver assistance systems, or ADAS, as it's referred to. Over 25 leading OEMs rely on our technology, and we have over 32 million vehicles that are equipped with Mobileye technology on the roads today. And we have agreements in place with 13 automakers to enable autonomous driving. So that's a snapshot of our company and what it is we're involved in. We want to improve vehicle safety, to reduce vehicle collisions, and to save lives. So some of you or all of you may be aware there are various levels or various steps towards full automated vehicles. Level 5 being the dream that everybody's heading towards is to bring full automation to the roads. But the first 2 steps, step 1 and step 2, are based around ADAS products or advanced driver assistance systems. And it's these ADAS products, this ADAS technology that's available today. And these are some of the vehicle manufacturers that we're working with and installing our technology into. Okay, so to give an idea of how the system works, all of our technology is camera vision based. This camera is installed to the front windscreen of the vehicle, and it's detecting the whole driving scene. It's looking for pedestrians, lane markings, road signs, traffic signs, landmarks. A great deal of information is being taken in, read by the camera and read by the processor as vehicles are driving along the roads. And the next one shows an example of how our systems, our ADAS systems, are actually detecting other road vehicles in front of us. We're calculating how far away they are, how fast they're traveling, what is the distance, and what is the chance or probability of there being a collision. The system will then make a decision on whether we need to apply the brakes or whether the driver needs to be warned to prevent the collision. And as we can see on the video on the left-hand side, this was a video back from 2005 in the very early days of our technology. But the fundamental way it operates hasn't changed since then. We're monitoring where all the pedestrians are walking in front of us. We're calculating how far away they are. Are they moving into our vehicle's path? Does the driver need to be given a warning or to be made aware of an impending collision? You can also see as the vehicle's moving left around the corner, we're not detecting on-street furniture. The cones, the bollards, and things on the sides of the roads are not of interest to us. We're only looking for, in this scenario, the vehicles and the pedestrians. Okay, so as well as what we're doing with the OEMs, with the automakers, we have a retrofit product that can be installed into any vehicle on the road today. It's a single forward-facing camera, and when I say camera, we should refer to it as a vision sensor. The camera's not there to record anything, it's there to monitor the driver scene, and a display that can be installed onto the dashboard. Now, this is the same technology that's built into the new vehicle manufacturers. Let's say we talk about BMW, with BMW's lane departure warning inside the vehicles. That's what we supply to BMW, it's Mobileye technology, and this can be retrofitted into the vehicles today. We refer to the system as a co-pilot. It's a third eye on the road. It's always looking at the road ahead, and it's always paying attention. The features that the system has are various life-saving features, and they all come in the one unit. The first one is a forward collision warning, where it's giving our driver an alert if they're about to crash into the vehicle in front. So whether our driver has been distracted, whether our driver isn't paying attention, or for some other reason hasn't noticed the vehicle in front of them has come to a standstill, our driver will get a warning to inform them of a collision so they're able to avoid that collision. Pedestrian and cyclist detection, which is very, very big. I'm working on a number of projects in the UK, in London, where they have a big problem with pedestrian and cyclist fatalities in and around the cities. And so we can detect around the vehicle for the presence of pedestrians or cyclists and again give the driver a warning. Lane departure warning, if a vehicle is unintended drifting from lane, we can control the headlights and dip the headlights and put the headlights back on again, depending on light conditions and other oncoming vehicles. Headway monitoring is telling our driver how many seconds away we are behind the vehicle in front. So we're encouraging drivers to keep a safe following distance, to always maintain 2 seconds behind the vehicle in front. If we can encourage the drivers to keep a safer following distance, there's going to be less collisions. They'll have more time to react if there's a situation. And the final feature is a speed limit indication, where we read the speed limit signs and warn the driver if they're exceeding the speed limit, so the driver is always aware of what the speed limit is. So I'd just like to show you some examples of the system in operation. This is a normal camera recording system in the front of a vehicle, but the vehicle also has the Mobileye ADAS system installed. You can see as we're following the vehicle in front, we're probably a little bit too close to that vehicle in front anyway, but if the vehicle in front continues to drive normally, there'll be no situations, there'll be no dramas. In this scenario, the vehicle in front suddenly applies the brakes because there's debris on the road, and the driver gets a warning, so he's able to avoid the collision. And you'll hear the Mobileye alarm in a second. Okay, so the driver was probably too close to be able to stop in the first instance, but he was able, as soon as he got the warning, was able to avoid the collision. The next example I'll show you is a bus driver in New York. You can see on the left-hand side there's a camera footage of the bus driver, and on the right-hand side the image is looking at the road ahead. And it's the bus driver's right of way as he's travelling along the bus lane, and just as he pulls towards the end, a pedestrian steps out in front of him across the crossing.
Damn.
Okay, so that could have ended a lot differently if he hadn't been given the warning and continued to drive. And the third example, again, is another bus driver in New York who's tired, same as lots of people are as they're driving in these conditions, and he falls asleep at the wheel. Okay, and I'm sure that's woken him up now. But you can see on the left-hand side that the passengers on the bus, there's no damage, there's no injuries, everybody's safe, the vehicle continues to travel, and that life goes on as normal. So it's prevented those collisions from happening. This is the world trend. Cities are becoming more and more congested with pedestrians, with cyclists, with other road vehicles. And as I mentioned before, it's impossible for all of our drivers to be aware 100% of the time what's happening around the vehicle. I'm going to talk through now just very, very briefly a case study of a recent project we've worked on in the UK. It was supported by Transport for London, the Transport Authority in the City of London. And the bus operator was Abellio. They have around about 1,000 buses operating in London for this particular operator. We installed the Mobileye collision prevention technology into 66 buses, and we ran the pilot for an entire year, for the whole year of 2018. At the end of the year, they compared the stats of number of collisions and number of injuries to the previous year of 2017. They reported a reduction in avoidable collisions by just under 30%, and an unexpected side benefit, which they weren't initially trying to achieve, was they reduced passenger injuries on the buses. And the passenger injuries reduced by around about 60%. And this is purely down to the fact that their bus drivers are driving the vehicles more cautiously, more carefully, and keeping a safer distance, so they can brake when there's an instance. They can brake safely without causing injuries. Okay, so we've spoken about the proven benefit with the retrofit ADAS. Just very briefly, I'll talk about what the next steps are and where we're moving towards with the smart ADAS. So this is the technology that we're using for all vehicles now, and also moving towards autonomous vehicles. And it's the same detection technology that's inside the vehicles. But using the smart ADAS, we're able to give real-time alerts on what's happening in and around the vehicle. Environmental changes, low clearance warning. And I know in the UK we have lots of problems with tall vehicles that drive under very low bridges, and they're crashing into the tops of the bridges. So we can read the signs and read information and report it directly to the driver. Traffic light recognition, weather condition warnings, changing lane markings where there's roadworks, and obstructions on the side of the road. So all this information can be taken in real time. And then also reported back on a driver behavior platform. So we can track and trace the vehicles, we can record who are poor drivers and who are good drivers, who's had the most Mobileye alerts, various information, so we can then look at it afterwards and do training with particular drivers who are causing problems or causing issues with collisions. There's also the ability to look for obstructions in the road. Maybe it's damage to the road, potholes, and monitor how they're growing and if the potholes are becoming increasingly more dangerous. And again, report this back to other drivers or back to a main portal. So also with the data, we can then use the data capturing tool to capture all sorts of information on the sides of the roads. So as vehicles are installed with the smart ADAS product, the camera that's inside the vehicle can read what's happening in and around the roads in front and capture a great deal of information. This is being used to do street sign surveys, lane marking surveys, obstructions in the road, maybe where there's foliage or trees growing over the roads. We've got projects running in the UK now with Ordnance Survey, who are the leading government mapping authority, where we're mapping the roads ready for utility companies. They want information on where manhole inspection chambers are in the roads, where entrances to driveways and properties are, where electricity cables are running around the roads, so they can build layer upon layer more and more data on top of the mapping that they provide. The more vehicles that are installed with this technology and able to capture the data, the more data that we can capture, and it can be used to making the city smarter. We've got functions where we can use to monitor parking spaces and free spaces in and around a city, traffic congestion, to report back where streets are congested, and so maybe the city can divert traffic into a different direction. There's many uses what we can get from a smart agent vehicle that's traveling and recording real-time information. And these are some of the smart city mapping initiatives that we've got underway at the minute, and some of the countries and cities that we're working in. I mentioned about Ordnance Survey in London, in Manchester, and we've got various other projects going on, which I don't have time to talk about at this minute, but I will be around for the duration of the conference, and would welcome to have any sort of more in-depth discussions about what we can do with our technology, and how it can save collisions and how we can capture data. Thank you very much.